This is the headset. That's okay. Let's see. Is this twist a little? I got it backwards. Yeah, that's why. Okay. I hate this thing. Okay, here we are. So welcome to the nostalgia session. Whereas my talk on Thursday was forward-looking, this is the inverse. This is a piece of history that might still have some lessons for us regardless. So the ancient Egyptians didn't use smalltalk, but I'll cut it short. We'll start in the mid-90s or so. So what is Strongtalk and why am I talking about it? Strongtalk was a smalltalk implementation done by a startup that was officially called Longview Technologies LLC, but might be known to some of you as Anamorphic, which was the code name, as it were. And what this startup did in a very different time, around 1994 or so, these people who write reports of analyzing the business climate and technology trends, Gartner, IDC, right? The world was wonderful. IBM was going big time on smalltalk. The market was growing. It was big on Wall Street, which is where, oddly enough, I was at the time. And everything was going to turn out fine. And so there was this perceived need for a fast smalltalk because the Wall Street guys, they were using smalltalk. Some of them still are, but they were using smalltalk in a big way because basically whatever limitations smalltalk might have in terms of performance or whatever, they don't care, right? That's just hardware. They can buy all the world's hardware if it'll give them, if they can do the arbitrage an hour before the other guy. They make money in the literal sense. So that's a great market, and so it seemed that if you could make it faster, that it was a great business opportunity. And so Dave Griswold started this company to do just that. And he had hired me a while earlier, and I didn't even believe him. I didn't think that this would really come about, but he promised, we're going to go and relocate to California, and I said, well, fine. In the meantime, it's an interesting job, and I was sitting there among all these bankers at the Bankers Trust Building on Liberty Street in Manhattan, which I'm sure very few of you know exactly where that is, but that is roughly from here to here from the World Trade Center towers, and it was just across the street. And well, anyway, I could get distracted and tell you all kinds of stories, like the first World Trade Center bombing in '93 and stuff. But we'll try and be roughly on topic. In any case, this really kicked off in September of '94. We moved to California just as David promised, and started this effort to really do a fast Smalltalk VM. And the best laid plans of mice and men, as they say, things don't work out the way you expect, because nothing like this had ever happened. In the 2 years that we did this language that nobody had ever heard of came up out of nowhere and took over the world, Java, of course. And so by the time we were out to sell this thing, the world had changed, and that all the Gartner predictions were not worth the paper they were written on, and we got acquired by Sun, luckily for us, because we had actually seen the writing on the wall. At least we semi-saw it. In late '95, we realized that, this Java thing, what if the hype really keeps going, this will be an issue, and so we stopped working on Smalltalk for a few months and did a Java VM as well, which basically, the Java VM was very closely related, of course, to the Smalltalk VM, and that technology became the hotspot virtual machine that much of the world runs on today. So that's basically the story, the core story of Anamorphic, and Strongtalk is a Smalltalk system that Anamorphic really built, and what it was, funded to build. So that included a high-performance VM. and various other features, and some of them are still research topics today. Some of them have been really realized and evolved, and so it seems that it might be worth talking about. So, high performance VM. What do we mean by that? So I found this deck of slides, original 1996 PowerPoint that I still have. And so mostly I converted the theme so it would look a little bit more modern, but this is a reminder of how far things have come, right? This is what PowerPoint could do back then, this blue background, and I don't know if you can even see it, but we can probably make it a bit bigger. So these were propaganda slides that were used by the startup to try and interest people, right? So interestingly, not coincidentally, some of these benchmarks are in the V8 benchmark suite today, because you realize that this VM, there's a direct line of descent from the self VM to the Strongtalk VM, and then in essentially forks more or less to Hotspot and to V8, because Lars Bach was pretty much involved. He was the lead on the last three and a key person on the self VM as well, and so it has Lars's fingerprints all over it. So these numbers we use, they're dated, right? And this is as I said, a nostalgia talk. But we took IBM Smalltalk, what became Visual Age, as sort of a base as one, because it was slowest. And these are numbers that were derived for VisualWorks 2.5, which was the current product at the time. So it's been a while. And of course, it's gotten faster over time. And these were our numbers. I'm taking all the credit for this. I didn't do squat on the VM, but that doesn't matter. Take credit where you can get it. That's if you take one thing away from this talk, that's what you should learn. So you can see it's like more than twice, almost 3 times the speed of VisualWorks on Richards at the time. 4 times as fast as IBM. Delta Blue, again, 4 times the speed of IBM, more or less, and more than twice as fast as VisualWorks. Most benchmarks were kind of 2.3, 2.5 factor over VisualWorks at the time. So it was pretty, that's pretty fast. In 1994, it was pretty much amazing, and it's still competitive. And of course, this hasn't been touched. Almost. That's not quite true, but it certainly hasn't been sped up since then. So we'll get to that. Oops, we need to unzoom. So I don't even know what these numbers mean because they're not consistent with the other set, and I suspect they're slightly later because they already use the term hotspot. But there's a graph, and bigger is better, and Strongtalk is the red stuff, so it's good. And here's another one of these historic things, so smopstones, slopstones, whatever they are. So these are kind of micro benchmarks, and again, the figures are pretty good. Almost 3 times the speed of VisualWorks. And I don't know, these VisualWorks apparently did very poorly on these for some reason, and we did spectacularly, which is why they're on the slide. Right, so this one's a little more interesting in a way because it makes a slightly more subtle point. So this benchmark is the dictionary key lookup in the Strongtalk dictionary class. Okay, then taking that same source code, not the lookup in those libraries of IBM or Park Place, but taking our lookup routine and running it on those systems. And the reason this is interesting is because that's a very crucial routine for performance, and it was kind of hand tweaked by whoever did those libraries very carefully to make it work. So there's sort of hand inlining. It isn't necessarily written as the cleanest abstraction you could because the cost of the method sends and so forth, it was not the textbook code that you should show people in terms of how you should structure your code. It's the textbook code of how you should optimize your code if your system can't do it for you, which it should. And so the differences on that were much more spectacular than on regular code in a way. It was pretty damn fast for regular code, but because it was the first, well, it wasn't quite the first, but no. It was the first system outside of Urs Hölzer's thesis to do some of these things. All the, adaptive, the hotspot technique of monitoring dynamically what methods are being called and optimizing, driving the optimization of that, and type feedback and all this stuff. So it did very well on high-level code. It would inline it for you. You didn't have to do as much hand inlining. And these other systems didn't do any of that, so they were pretty bad. So you got a factor of 15 over VisualWorks, right? Now this doesn't mean our actual dictionary class was 15 times the speed of VisualWorks. It was more like 2.3 because VisualWorks had hand, Workplace had hand tweaked this. But if you took our code, if you wrote nice, high-level, beautifully structured code that just, method do this, do that, the difference was huge. And this was one of our arguments. This is how, you could code the way you should. So that's very nice technology. And so it overall was not too shabby. Here's another one which I'll demo for you. And this is curious in its own right because, again, it brings up some new points. So this is computing a Mandelbrot set. And as you can see from those numbers, the results are not too shabby. They're dated, like all these numbers I'm giving you. Now the other numbers are dated because these systems have moved on, like VisualWorks and so forth. The interesting thing about this is this last bit, right? So this was about 60% the speed of C with optimization on. That's actually pretty damn good. There are not a whole lot of problems that you can't address with that kind of performance. The numbers now are a bit different because the C compilers have moved on and the architectures have changed and all kinds of things have happened, right? Which is not to say that you can adjust this, but this code is essentially the code from 1996. The only difference is there's one guy who's really taken it seriously since I managed to get it open sourced, and he's played with it. He's done a port to Mac OS and things like that, and fixed some things and probably destabilized others and whatever, right? So it's not exactly the same code, but close enough. The actual release that we put out in 2006. I can't get it apparently to run on my VMware Windows 7 for whatever reason, so I'm using Steve's code which is fine. But the numbers are not the same, and I'll show you some of this stuff. So let's see. We want to get this guy out of the way and find this, and that it's alive and. So let's just. Hopefully, I apologize for it coming up so slowly because it was running on VMware. But maybe you if you try Eclipse sometime, and Smalltalk already even has a reputation for coming up fast with an image and everything when you compare it to Java. This thing, especially if it's running on an actual machine, it's just instantaneous. This is the way things were supposed to be. So let's see what we can actually find here that's relevant. All right, so we have our little demo of the Mandelbrot set, and I'm going to bring up a few of these. Hello, one here, one more, and then I'll find what happened to the last one. Oh, don't do that. Go away, we don't need you right now, I think. So we want to line these up and then we'll kind of zoom. And we want our original launcher wherever it is. Hello? What happened to it? This, we want this guy. And we want to put this away. We want to see if we can make anything bigger. Kind of in the picture, and see. So what happens here? Each of these, there's an option menu on each of these little windows, And the options are boxed floats, optimized floats, and call C. I don't know if you can really see this. So boxed floats is just running regular Smalltalk code, right? So this is essentially refers to the core routine that's doing the computation of the Mandelbrot loop. So you have the option of running this with either the regular Smalltalk code, straight Smalltalk code, with this thing called optimized floats that I'll show you what that is in a moment. But we're going to set one of these to box floats and keep this one on optimized floats. And this one is supposed to call C in the inner loop. And this is where those numbers come from. That's what when we mean for optimized C, we don't really mean that it didn't really mean that the whole thing was written in optimized C. It meant that the thing that dominates these things is that inner loop. The rest really doesn't play a big role. So if we run this, well, we can run it, but I should probably show you what this is about first. So let's try and find it. Right, so this is the class that does this, and this is, okay, so this is a slow iterate. Doesn't really matter that much, and I have no idea, what this code is exactly doing, but it's the inner loop of the Mandelbrot thing, and it's just straight Smalltalk. Is this big enough? Can you see this, or I can? You guys are easy. The guys with
That's the first brain.
The brain fun.
So this is for the most part straight Smalltalk code. You're wondering what the blue stuff is, right? So the blue stuff are type annotations, and we'll talk about the Strongtalk type system. But as a rule, the type system didn't play any role in optimization. It's there for documentation. We had these thoughts of using it for tooling for what now is called IntelliSense and all that. Not much of that got done, but we were thinking about this back in the mid-90s, long before the Java environments, before the Javanese discovered the IDE and so forth. So you can use types for many things, but it was not used for optimization at all. That's a common misunderstanding. So it doesn't really matter. But what's different when you do the optimized floats was an experiment, the one place where we tried to see what would happen if we did use types for optimization. So if we look at this guy, this is the stuff that runs when you do optimized floats. So there's floats. Float is just means that whatever object here, we are going to check that it conforms to the protocol of the float class. Any object we don't know, we know nothing about its implementation, we make no assumptions. It's consistent with the Smalltalk philosophy that your behavior is what matters. On the other hand, float value was this magical thing that was just done as an experiment. And float value was this one special thing that we tried that says, yes, we swear it's a float. It really is a float. And of course, the compiler didn't believe us, but it did intra-method analysis. So this helped guide it by giving this information that we are asserting that it's a float, and it would check this, but only within a method. There was no inter-procedural kind of work done on this. So basically, but these are all the variables that are being computed here, so they're being treated as float values, and that's what gives us the optimized floats. Okay, so that's the difference. And to tell you the truth, I haven't figured out where the code that does it while calling C is. So I'm not going to show you that. Truth in advertising, or at least semi-truth. So, mini-truth, yes, exactly. So let's see what we can do if we run this. And the numbers will vary, because this is an adaptive system, so the more you run it, things change, the compilation can kick in, but the proportions are roughly the same. So if we run this thing, it's doing 2,000 iterations, and you can see it slows down in the middle where things are deeper, and so yeah, 2,000 iterations. So that's what you do. That's what it does with straight Smalltalk code. So let's try the optimized float version. It's a little bit faster, and the numbers, which vary a bit. On a good day you might get 4 seconds here. Now it's 5.5. On a bad day you could get 6.5. It all depends. You get roughly half a second for this guy, plus minus. And then, of course, we can try. Hello. We want to be able to see this. So this is C. And if you really look at this, you can see that it's faster. You can still perceive the hesitation on the optimized float case because it's more than half a second. This guy is, 200 milliseconds. Most people can't see that. So it's instantaneous. And that's roughly the ballpark. It could be 170 or 270. Depends on all kinds of things that are beyond me, frankly. So C is pretty fast. But it's interesting that we can get within, so this is not 60%. This is more like 2.5 times. So it's maybe 40% of C. Depending which run, but it doesn't do as well. But the point was that you could get to 60% of C. And you probably could again if somebody who knew what he was doing took a look at this. So that's pretty respectable.
Yes, in particular, Gilad, not that it's relevant, but are you comparing x87 code in the VM against SSE code in the C code?
I'm sure you know, but I don't know what I'm comparing. Right? This is I'm just a salesman. You're probably right. Right. The point is that so much has changed that I can claim that. Okay, I just have to remember the words in the right order. Okay. So now what happened to my presentation? Okay, let's zoom out a little so we can see what's going on. Anybody see it? I think that's it. Hello? No, that's the directory. You're right. So you see it. Mariano sees it, but I don't see it.
Just select your keynote icon halfway down the menu bar.
Oh yeah, there it is. Yeah, it's funny when you're trying to find something you can't see it. Right, so we can go back to play. So that was the story of this benchmark. Does anybody know when we started? Just to help me time this. Probably a quarter to? Yeah, okay. So then the rest of these slides, they have lots of bullets. I changed them to the Newspeak theme, so the bullets are the Big Brother's eye. But there's lots of bullets. I don't actually like the style of these slides, but they're almost literally the slides that except for converting the theme in a few edits here and there, they're very much the slides from '96. So I was lazy, and it's kind of interesting because it gives you a sort of period sense, sort of like sepia kind of. So current being late '96, 2.5 megabyte heap, 1 to 2 megabytes for compiled code, blah blah blah. So these numbers, mean that it'll run nice. If someone could, the only thing I can think at this point that's really relevant to do with this, honestly, is to get it get it robust and get it to compile to ARM, because this thing was developed on 90 megahertz Pentiums with 32 meg of memory, which were the latest and greatest things we could get at Fry's in September of '94. And since no one touched it since, everything gets faster and smaller if you don't do anything to it over time. And so these numbers are pretty nice. So this is actually true, it's a bit of marketing speak. It would run in 8 megabytes. Run well is Dave had a flair for sales. But it certainly ran very well in 16, and it did run in 8, but depending what you're running, right? It doesn't, by today's standards, it isn't a very large footprint system. I don't know if we tried to run something sophisticated like Eclipse, but, we're not that advanced. The inlining database. So here's a thing that, as far as I know, still isn't there. I don't think anyone's done that since, right? So just as the Java VM, the hotspot VM does, this thing inlines things as it dynamically, as the computation progresses. It monitors what's being executed very frequently, and then tries to optimize it and might inline stuff. And if something changes, like a class is loaded, or in our case something gets changed reflectively, then things get de-optimized, all that nice stuff. The thing about this is that you get that performance. It gets better and better over time as the dynamic compilation happens. But you don't want to do this, especially in a client system, all the time. You would like to have learned those lessons. It's likely that your execution profile isn't that different for a given application. And so it would collect the data, the decisions made about inlining in a database such that you could actually, then not have to wait to execute it to tell. And you could immediately apply those inlinings when you started up. And I don't think that it's ever been put into the Java system. So this is still a feature that nobody has yet. So that's kind of cool. Future plans for delivering executables. Nothing ever changes. I mean, this was stuff we were thinking about in '94, and people are still doing it and discussing it now. And that's kind of curious. So we didn't actually do that, but we had ideas for doing this. And again, there was a talk the other day about essentially this application extraction, how to minimize and find out. Right, this is a problem in Smalltalk. Now this no longer interests me because in Newspeak I've basically done away with this problem. Right, there is no problem about extracting applications in Newspeak. You know exactly what your application is and what its boundaries are. So we can always put out minimal things like that fairly easily, and we do actually have a facility for producing executables, but they're still bloated because the underlying squeak image is so bloody big, and that is still a problem, how to compact that. But anyway, these were our assumptions, and remote reflective operations is a good segue into the next topic, which is mirrors. So mirrors, I mentioned that a little bit in my talk on Thursday, and in particular in the context of the object capability idea and security, but there's a lot more to mirrors than that. And mirrors go back to self. A lot of really good stuff goes back to that work. So just in terms of the timeline, right, the self project was canceled by the management at Sun Labs in the summer of '95, I believe. Lars Bach, who had been part of this self project, joined us in September of '94 because he could see where this was going. Lars is really good at seeing where things are going. And so he escaped that. And so about, let's say, outside, 18 months later, Sun Microsystems purchased that technology back when they bought our startup. And this is one of those rare instances where you can put a price tag on a management decision very directly, because they didn't have the money to pay five people in the lab to do this, and so they bought it back a year and a half later for an order of magnitude or so more than it could have possibly cost them to do it in-house. Because obviously this technology wasn't relevant to anything. They did this because they decided to go for Java. Of course, then they found out that in order to run Java, they actually needed the right stuff. So anyway, it's curious, but it just tells you how hard it is to manage research. And you basically have to know that exact subfield and be very good at that exact subfield to make the right decision. And someone who has to manage all the lab with all these things is basically managing 20 different things of which they know very little about. And that's why things run so well. So in any case, one of the things Self did, they then came up with this concept of the mirror. And Strongtalk was, I guess, the second system to use this. Interestingly, again, around the same time, when we went public with Strongtalk in Uppsala at October of '96, Alan Worf-Brock gave a keynote, which was about, what was it called? Firewall, I think? Does anyone remember what that was called? All right, so he had done basically a mirror-based system as well. He didn't call them mirrors, and his emphasis there were issues like deployment and distribution. So Smalltalk is a wonderful environment. One of the things that's great about it, right, is you can modify the environment you're using on the fly, right? It's live. This is wonderful until you modify it the wrong way and shoot yourself in the foot. And it's surprising how rarely that happens, but it does happen. And one of the things that Alan showed is how he could basically run one image controlling another. Right? So he had one environment where it was talking remotely across a process boundary to another, and he could change object and screw it up and nothing would happen. I mean, the one he was controlling was broken, but he could see that, and his environment continued to work. Right? And this this extends, once you've crossed that boundary, you can do it remotely and so forth, which is still an issue now with cloud and stuff, debugging remotely and so forth, right? It's still a problem that isn't addressed terribly well, right? Java debuggers, JDI, the Java debugging system architecture is based on mirrors. Coincidentally, just because Lars and I were whispering into people's ears about that, because they started the debugging architecture without that, and Java being multi-threaded, when you tried to stop all the threads to get it didn't work for them terribly well, let's say, right? Things tended to lock up. So they wanted out-of-process debugging anyway. And so effectively it is a mirror-based architecture. So it's good for distribution, right? Because you can you don't care what the implementation of the mirror is. Maybe I should explain better what mirrors are, because maybe not everybody was here Thursday and so forth. So classic system, right? Everybody copies reflection from Smalltalk. With all due respect to the list portal, when you're talking objects, it's all copied from Smalltalk, including the CLOS model is copied and, shall we say, elaborated. But basic model, right? An object will tell you what its class is, and the class is the thing that models these things. It has methods to let you, change methods, add methods, change instance variables, blah, 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 do whatever it knows how to do. In a system like Java, it only an introspect. It can only tell you what's there. It can't change anything. But it's still that same architecture in the sense that that the class is the thing that controls the access to these reflective facilities, and every object will happily tell you what its real class is. And you can't muck with that, because things will go wrong if you try to override class in a typical system. So the idea with mirrors is that you take all that out of the objects. They can still tell you what their class is, but the class isn't really intended to do that reflective stuff. The mirror is an object that reflects another object. That's why it's called a mirror. And so if you just have an object, nothing, you can't really reflect on it. You need the mirror on it. And what the mirror does, in order to write reflective code, you have to talk to this mirror API, and you can have different mirror implementations. Maybe they talk to proxies across the network or in another process, and that's how it makes it really, if you actually build your environment around these, if you do your mirror API right and consider the fact that distributed things can fail and various other issues, then you can actually write it such that it'll work the same whether the thing is local or remote. And so you can do remote debugging and so forth. And then you can change your local environment independently of that. And in particular, you can change the remote thing and say, what if I change this thing in object, and see if it works. And if it doesn't work, you change it back because your environment's still live. So that's all good for distribution. It's good for deployment because you can take it out very easily. Again, you don't have to deal so much with the spaghetti of, well, is anyone calling any of these methods anywhere, etc., etc. You just, is mirror being used, because that's the gateway of everything. And so it's relatively easy to find out that this code is not using reflection, and I can just take it out. So that's mirrors, and they were all there, and I suppose, you shouldn't believe me, so I should show you. I mean, not that there's much to show, but let's get rid of these guys. And we don't really need that. This is all kinds of, so this is Steve's development thing, so it's telling you, that's the heap it has, and it garbage collected and all kinds of stuff that some people here are probably interested in, but we're going to put it away. And somewhere we had the launcher for this guy. Hello. Oh, this is the launcher for this guy, right. What did we want to show you here? That there were mirrors, so let's look at mirror. I mean, looking at this API today, it needs a lot of work, but it was a first. So let's look at the hierarchy and make it a bit bigger and expand things a bit so we can see the whole hierarchy. And hello. Oh, this is just So this is the mirror class hierarchy, which is too complicated, and this is not in the original. This is something that we put in because there's a work in progress of a port of Newspeak to Strongtalk. So it actually does run, but it doesn't run the IDE. because the mirror system isn't the right one. Actually, that's the key issue there. So there's work to get it. So I can't show you Newspeak programs here, but I can actually run Newspeak programs in this image. Well, it's not an image. We'll get to that. But other than that, yeah, there's a bunch of things. The most interesting ones are things like, let's say, abstract class mirror. Hello. Right, so let's find something. Where did we have interesting things? Right. So there's all kinds of stuff, but there's like subclasses, direct subclasses, is meta, what the mixin is. We'll talk about mixins in a moment. This API, I'm not happy with it, but I'm actually more happy with it than the one that is in Newspeak right now. But we're almost done with a new Newspeak mirror API that I'm actually really happy with. It really is working the way it's supposed to. Elliot?
Do you want to spend 2 sentences drawing attention to the UI and its connection with Hotspot?
Well, I can do that now. It's down the line somewhere. So the UI. So this is not your grandfather's Smalltalk UI, right? It's different. Its connection is to self, right? So this whole kind of tree-like thing, right? You know, you have a class here, and we can open a method here, and we can open another method here side by side, right? So it doesn't work like the classic multi-pane browsers. And this is an idea that originated again, well, where the UI idea originated, I shouldn't swear, but in terms of IDEs, it originates in self. And so the influence is carried through, and to an extent this carries through to the current Hopscotch API, which is so much better than this that you can't believe. I mean, this thing was very nice because you could see methods side by side, but you would end up with lots of windows, which is to some extent a problem even in the existing Smalltalk classic API, but even more so here. And Hopscotch does away with all that because with the navigation paradigm, I basically work with one window. So I believe Vasily finally got it the way it's supposed to work. But this is the second iteration of this idea. Hopscotch is sort of in a way the third. So it is different, and there's lots to say about this UI that's actually interesting, and we'll say a little bit if we get there. This is actually taking longer than I thought. So anyway, there are a bunch of, it really doesn't matter what the details are, I just wanted to prove that it exists. And, well, let's unzoom. That way we can see where we are. And we'll go back to our regular scheduled program. Right, so part of this is historical, right? So mirrors, this was the first system to do mirrors in a class-based language. It's the second system, more or less, to do, well, okay, Alan actually had it in parallel. He didn't call it he didn't call the mirrors, well, he gave a keynote, right? He understood the idea, he demoed it to what extent, right? For some reason it never found its way into any of the Park Place Digitalk products, but then that's the way the world works. So the apart from the fact that we were one of the first to do this, again with a self-connection, it's an opportunity to explain some more of the advantages of the idea. And if you're really interested, go to my website. There are pointers to. I gave a talk to Robert Hirschfeld's class at HPI, which is, I think recorded somewhere. Well, at least the slides are there that go into mirrors in gory detail. Here's another difference, right? So images are a double-edged sword. So Strongtalk didn't have an image. What you're seeing there is not an image. What you're seeing there is just a running IDE. It's essentially a running application. And yes, you can change classes on the fly. You can do all the Smalltalk things, but it is not an image in the sense that it does not persist the state. What you can do is save your program. And so, for you know all these problems that images have, right? You can screw yourself up in various ways. And we've been having these interesting discussions with about getting over some of these problems, right? So as Alan said in his 96 talk, right? The bits, the actual running product, had not been reconstituted since 1976. At that point, it was 20 years where no one had actually built the damn thing from its source code. no one really, how do you actually know what it's running and what's there? So the image is a useful thing to have, but it is far too central to Smalltalk practice. It should not be the main thing. You can certainly run very nicely without it. In our experiences, it worked very well. And maybe I can show you that. So I need to change something and then kill it, basically. So let's find something to change, like a demo class that won't do any harm, like bank account. And so you can do various things. So this is bank account, and I'm going to erase the types here. So again, you see, I don't know if you can see, but when you modify things, it sort of stands out. And when we, so before I actually do the modification, maybe you should see that bank account really works. So bank account new credit, $100. There's a bug here that you actually have to select it. So here's an inspector on a bank account, and it has a balance of 100. So I think you can sort of see all this. And this is a bank account class, and now I'm going to accept the change, right? So I'm going to get rid of the types, and I can actually probably type check it just for fun. See what it has to say. So it's complaining that there's no type here. So there's a type error because there is no type. If there was a type, we can show you, various problems with that. This is showing multiple things, so we're not going to talk about all of them. But we can go back to this guy. And now it has accepted it. If you look at this, despite the type error, it's accepted the code, right? Because the types never prevent you from, it isn't like a typed language. It's optional. It never prevents you from accepting your code. It just tells you, oh, I think there might be a problem here. So if you notice, it's inset, again, the method window. So that's an indication that there's no actual change going on. It's whatever is in the system. And so if we go back and do this again, we can still run it and get a bank account. Nothing has really changed, and we've erased the type. So I might as well show you that because we're going to be talking about the types in a little while, assuming anyone's still interested. So yeah, what I wanted to show you now is I'm going to kill this off. So I've made a change, right? I have changed the code, and I think if I kill it, so where is it? I want to kill the launcher. That will kill off the rest. And I'm just going to brutally slaughter it. And we're going to find out where it came from. Yeah, that's what we want. We're going to bring it up again. And now it came up slower because it's printing these various complaints. But you see, when it comes up, it tells me stuff. Things are not as they should be. So because there was no image and we didn't save anything. But what we can, we do save every source change to both the changes log and what we call the source database, which is basically a big directory full of files because we never had time to actually do a real source database. And so what you can compare is the dates on the source changes to the dates on the binary. And so it can tell you that there's a problem. And it gives you a button here to basically sync them up again in the sense that you want to roll back your source to the date where it was consistent with the binary. So that's the first thing you do. Now this is different than the way it used to work. Steve changed this, and I confess I don't like the way he changed it. We used to have a button here which basically said, make it all good. Take the source now that was out there, suck it in, so that I'm back exactly where I was. So basically, you have a crash, you have a problem. You just bring it up like that, and you're back where you were. 2 buttons. We found as a practical matter that this was way easier to work with in a lot of ways than an image whenever you have problems. In particular, this is a system under development which was pretty damn unstable, so the crash is not a hypothetical scenario. And we were running on Windows NT and stuff, so there are other things that could crash as well. So anyway, but here he's changed it, so instead he gives you the restore file, which has a history, I guess, of what's been changed. I don't know that it's an old, okay, so this is, I don't know why this is all here. So you don't want to do this, in my opinion, but it gives you more control, right? You can manually, right? But it's also more like going and getting stuff out of the changes file. I don't like it, but it used to work better. The point is, this is a model without an image. There's a thing here called a Bst file. Just go away. Yeah. Where is it? Right. So, see this guy? That's the binary. Let's see if we can move it a little bit so that you can see the sizes. Hello. Okay, so it's about 3 megabytes. It's bigger than it used to be because, I don't know, there's more stuff in it than it used to be, but that's actually our binary representation. This is a binary representation of the program, of the classes and methods, not an image. It isn't, there's no state as such in it. And what the Strongtalk virtual machine does, which is basically this application right here, except that this one has a Newspeak icon because it's the version that Steve is working with to integrate Newspeak into it. What that does is it reads that in, right? There's C++ code in there that just reads that binary format in, basically creates a world and starts up the application. There's an entry point, I forget what it is, it calls something and that starts up your Smalltalk world. And as you can see, it's wicked fast. And you know, on a real machine without VMware in the way and stuff, you know, tens of milliseconds, and it's all up. The windows are there, so it's nice. And so this is the binary Smalltalk whatever format, whatever we call it, that these Bst files. So no images involved. So that's different, and actually a useful thing, because I think, as I say, your images, it would be nice to have an image option. In fact, if probably on the next slide, eventually it'll tell you that we were thinking of adding this. Right here it tells you that this is the Bst format, etc., blah blah. And yeah, traditional image save uppers can be added. I think it's useful to have an image as a technique. It's very useful not to have an image. And again, this is one of those things, forces of habit, that the Smalltalk community is stuck on. And, you know, it's only 16 years since we did this, so maybe...
Yeah, about that.
Yeah.
What about well-known objects, like true, nil?
So, I don't actually know the answer off the top of my head, right? There's probably some things, you know, done to create them, but you could also create them on the fly because it only matters for that running process. So you don't actually have to have anything there, but you do have to populate the Smalltalk dictionary and things. So there is code that does that, and how much of that is? Most of that is probably Smalltalk code, right? There's this tricky transition routine. If I really try, if we go offline, I can probably find it for you. So anyway, let's talk a little bit about the type system because we're running late. So the purpose of the type system, as I said, was not performance. The purpose of the type system was, at the time actually it was sort of motivated by something I no longer believe in, which was sort of correctness, early error detection, blah blah blah. It does do that, but I don't actually believe that matters. Overall, you know, yes, occasionally we could show you cases where you would find something sooner, but it doesn't really matter. The great advantage is the fact that you could read the APIs. Right? This is something that, believe it or not, Java does do some things right. Java doc, however primitive, this idea of just taking these ugly meta comments and sticking out HTML, is an effective tool if used with discipline. At least if you look at Sun's libraries, it's very good. Other people's libraries, if you don't use it consistently, you don't get good results. But the fact that you can just see what the API is doing, the types are very valuable as documentation. Their big value is also documentation for machines. Now, of course, if you talk to people now, they'll tell you, oh, you can't do refactoring without types, and then tell them, excuse me, do you know who invented refactoring? But regardless, you can actually do refactoring better with types. It helps. You have more information to work with. It's documentation for the machine. And you can do all these cool things like, name completion and things like that. So it's nice to have as long as it doesn't get in the way. And in Strongtalk, it doesn't get in the way because it's completely optional. I show you, you can erase the thing and nothing happens. This was I wish I could say that we were so clever that we planned it this way, but it's just that we started, the first implementation of the Strongtalk type system was done before the actual VM work was done. It was done on top of Park Place, and we couldn't change it, the underlying system. And so we were forced into this model. Because I had come out of the university with all the garbage they teach you there, and it's taken me years to unlearn all that stuff. But you assume, I should have a type system, and of course, then I can change the semantics, and we want to do reified generics. We really did, but we couldn't, thank God. So it really was a constraint. Sometimes constraints are really good. This doesn't matter. I'm just going to show you some of this stuff. It's more, not too much, because this demo stuff takes too much time. I don't think I have a running one anymore, right? So let's bring it up again. VM is in debug mode. Okay. Why is it so slow this time? We can go here and find, again, bank account. Oh no, we'll find something more interesting. Let's start with Boolean. So this is the Boolean class, and so here's like if true, if false. If true and false, these are type signatures for if true or false. One of the reasons type checking Smalltalk is hard is that fairly advanced type concepts like higher order functions and contravariants and all this weird stuff, which probably doesn't mean much to most of you, but you need fairly advanced type constructs to get anywhere, because you can't. In an ordinary language, if is a built-in construct. There's a built-in special rule for what the type checker does when it sees an if statement. And here, it's just another control construct. And so you have to have enough generality to cope with that. So what these annotations are telling you, that the types come between angle brackets after a parameter or a variable or stuff. And as I said, it's syntactically completely optional. You can erase it. It never changes the meaning of the program. And they're highlighted in blue here. And this is actually a fairly advanced type. We saw before in bank account, we saw types like integer or something, names of classes basically. Though it doesn't mean that it's that implementation. It just means it's something that has the public methods of that class. But here, the first parameter has to be a block. And the syntax for a block type sort of echoes a bit the syntax for blocks, right, with the square brackets. And it's a block that returns an X. Now what's an X? The def word here tells me that we're defining it here. It's some X, it'll be defined by the type of the block parameter. Send it a block that returns some type X. Okay, and send, if false, another block that returns some type Y, and you're going to get either an X or a Y. Okay? So that's actually what happens. And you sort of need that because you can easily write code that returns objects of different types, but they have some shared protocol, and you have to figure that out, and it kind of copes with that so that the result of the if expression is actually usable, and the type checker doesn't scream that you can't do it. It gets fairly complicated. The nice thing about types is they are a lovely intellectual riddle. The bad thing is it's so little bang for the buck. I mean, you can spend so much energy on them and get nowhere. Believe me, from experience. What else do we have here? Right, so the blue thing tells you that it's an abstract class. That's just we recognize self-subclass responsibility. And, historically, this is probably the first time this was done, right? Now every Java environment has 20, colorful little things. It gets overloaded. But But this was probably the first time that anyone had actually started putting that information in the ID. So that's like a Boolean. And another interesting one to look at is maybe collection. And I could spend the whole hour, obviously, talking about types. And I get the feeling it'll put you to sleep. So, yeah, let's look at something easy like do. Right? So do, what does do take? It takes something called f, a function f, and that's a block that returns e. What is e? Right here, collection of e, right? It's a generic type. You've probably been forced to exposed to my work on generic types in Java, so at least as a result, this shouldn't be too unfamiliar to most people, right? So it's a collection that holds things of type e. And what does the block that you send do to? It's a block that takes e's. Doesn't matter what it does. We don't have an interest in its result type in a do, but as long as it takes an e. So that's a relatively simple signature. Thing like collect is a little more elaborate, right? So it takes a mapping function, right? And that takes e's from the collection, but it does some computation on them, and in general, any computation it wants. So it produces some type R, which is defined by the type of that block, right? So it's a block that takes e's and produces R's of some type. Yeah.
The returning type of do, if you don't put anything like void or something like that.
It's self. It's the type of the class.
But you have to receive.
No, if you don't put a return type for the method, then it's self. Capital self, which is a type that is dynamically bound to the type of a class. Andrew?
Yes. And if you have a method, if you have a subclass where the method that is inherited from the superclass will require arguments with other
a different type.
You have to to redefine that?
Well, if the subclass is overriding a method and the types it takes are different, there are rules for what is and is not type safe. They're looser than the Java rules. It's pretty smart about that, but there certainly are restrictions, and there is valid code that won't live up to those restrictions because you know you're going to use it in this particular way. But essentially, the key rule is the contravariant rule, right? So the return type can be a more specific type, but the argument types have to actually be less specific. And this is hard for people to, and I don't have time in the next 6 minutes to go through that, but that's how it works. Alex?
Yeah. Quick question. So is it really for documentation purposes that you type the collection library?
Well, that's my post hoc argument that that's the useful thing about it. I believe some, it's nice to know that it's type safe, right? I just know that, you can develop perfectly valid smalltalk code and wonder it works without ever being type checked, right? And it can be solid and robust and industrial strength and all the stuff they tell you, in university about how types are crucial is a load of hogwash. But the purpose, we did type check these classes at various times. I don't even know right now whether it would pass the type checker, but we were interested. At the time we believed it would catch errors, and it did catch errors, except that, I don't believe that it matters. They got caught anyway early in development. So anyway, as a result of this, we get back a collection of type R. And CLTN is just an alias, a shortened thing, because they didn't like to type long names. I believe that's a mistake, actually, to have introduced these aliases. But anyway, I'm not going to go through others. Some of them are more elaborate. The thing is, it turns out that the things you're used to, like detect, select, if you actually try to think what is going on there type-wise, it's fairly involved. And you need fairly powerful constructs, because you need essentially higher-order functions and generics at the method level and all kinds of stuff. And it's... and you need to make this work. You need to engineer this because it has to work in an interactive environment. It's very different from the traditional batch compiler that does type checking, because you need to do this on a method-by-method basis. And there was this constraint at the time that wouldn't be an issue now, that we were not allowed to use any memory unless we were actually type checking. right? The argument is we should come to Smalltalk people and say it won't cost you anything, zero, unless you use it. So we can't work like Eclipse and pile up memory and keep type information in memory all the time and stuff. So it has an LRU kind of cache that it was a bit much more painful to implement. Plus the fact that I didn't know what I was doing and no one had really done this sort of thing before. Well, the Trellis Owl people had, but that's the only case where someone had actually done an interactive environment with types before. So there are lots of problems. The code I'm not proud of, but it does, at least it did work at some point. So again, this is something that we can learn from because it would be useful. When someone comes to you and says that, they won't use a dynamically typed language because they can't live without their IntelliSense, blah, 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 right? Because Eclipse is such a wonderful IDE because it can, complete the names as you type, and that's addictive. People like it. It works well. There would be, I still believe that there is benefit in having such a system. Now I've moved on to Newspeak, and Newspeak is harder to type than Smalltalk. It's more dynamic and it's actually harder. It's still an open problem, except that I'm no longer willing to put it at the top of my list of priorities because I spent too much of my life doing types. Blah, blah, blah. Yeah, sure, you can still run Smalltalk code, all this. Mixins. We talked about mixins the other day, but we'll quickly go through them again. So as I said, a mixin is basically the part, this is an example here. I don't know if you can see it very well, but again, that's what the slides, the theme conversion didn't work very well for this one. Class color point inherits from point, has a bunch of color stuff, right? The stuff that's in bold, right, this stuff, that's what the mixin is. That's the contribution, the delta that the class adds to point, right? And you want to isolate that, so it'll look something like this. Mixin color, it's just this thing. It doesn't have a superclass, it doesn't depend on a superclass, and it can be applied to different superclass chains. So this is, again, something that, traits were pretty much inspired by this. So I can take the argument of why I think traits did not really, my thesis work was partly about mixins and partly about extending mixins beyond that. So this was a conservative thing we put into the system because we never really did all the things we could do. Traits are somewhere between mixins and what I did in my thesis. But mixins are a good point to an engineering point because they're easy to implement. They're especially easy to implement if you do it right. So mixins are in the Strongtalk VM, right? The base representation the VM uses is mixins, not classes. Classes are just a veneer, again, for people to be comfortable with. And that's something that hasn't been done since. This is still the only implementation of mixins that is really done properly, without overhead, without having to copy. We can talk about how it's implemented, but we won't do that today because we're almost out of time. The point is then you can mix this stuff, right? So once you have this color description, you can put it into points, you can put it into circles. We actually use this. Quick example of somewhere where it's used would be, I think it's called region. So, is that region? Let me see this hierarchy. Okay, it's a subclass of region, sorry, this guy. Come into the middle so we can have it. So, a composite region, this is some sort of GUI, part of the GUI framework, right? So you have areas, and you can have areas made of multiple areas. So composite region behaves a lot like a collection, right? It has elements in it that you would want to iterate over with do, etc. And you don't want to replicate that collection code. So we mix in collection, even though it's a GUI hierarchy that is completely separate from the collection hierarchy, we can mix it in. And we can do that with any class, even if we define it as a class, because, as I said, the classes are a veneer. You can always extract the classes mix in. So that was a kind of a nice feature. And in a way, that's still there, in a way, in Newspeak as well. Anything else that we wanted to say? Told you all this. Flyweight glyphs, yeah. Run a couple minutes over time, is that okay? Yeah.
Quick question.
Yeah.
From the point of view, the VM was
what was the benefit of mixins?
From the point of view of the VM, I don't think the VM benefits from mixins, but the VM isn't here to benefit, it's here to benefit us. So the benefit of mixins is to the programmer. From the point of view of the VM, you can implement it essentially with no overhead. There is a paper that I can point you at, which was in a workshop, so it never got published in a proper proceedings, but it explains what we do there. Essentially, the method dictionary for the class delegates to a special method dictionary for the mixin. Most of the code can sit in the mixin. You need to copy down certain things like instance variable accessors, and there's different ways you can do super. In Strongtalk, we copy down super methods. In Newspeak, we have a bytecode that avoids that need because it dynamically looks them up. We can talk about that.
What about the states?
So the point is the instance variable, you are always going to an accessor. Even though this is Smalltalk and you write things, it actually is always an accessor. And Strongtalk VM is good enough that it's never an issue. These accessors have to be copied down because they have to be specific for every class because its structure is different.
So these instances, these mixins are not runtime mixins?
Sure, they're runtime.
So you can add mixins in runtime to an object?
Sure, you can. You can dynamically apply a mixin at runtime reflectively and produce a new class. Once you have a class, then your object has a particular class, but the code is shared. Almost all the code, except for these cases like the instance variable accessors, which depend on the actual representation of this particular mixin application, those have to be copied down. So there's like a hierarchy of method dictionaries, right? So that gets done actually lazily the first time you call it. It isn't done in advance. So I can point you at the text that describes this. Yeah. Okay. Last thing that's kind of cool because it's eminently demoable, even though. Let's shut this down and start afresh because I don't know what we have. Hello. And one more time. Right. So you look at these guys. Doesn't really matter what it says, but this is text. This is kind of a sort of HTML-ish thing that we did. And HTML was new back then. And so there are these Smalltalk applets embedded in it. So if we do this expands into an object browser. And if we do something else, like let's evaluate something like ordered collection. So I've got this ordered collection, right? And I can add things to it, right? So I can do that, right? That's pretty standard. What is a little bit less standard is this menu entry. Can you see this? Yeah. So it says build do it button there. So now I've created a button that when I click it will execute the code that I had selected. So I can go click this guy, right? Now the thing is, this is still the text pane that we had before. Okay, and it still does its thing. Right, so the point is that every text editor in the system, those little method editors that you saw where I added the methods, right, all of these, you can put arbitrary graphic live objects into them. And it's not, and this is less dramatic, of course, than in 96, but, you've got HTML everywhere, but you rarely see an actual editor where you can dynamically do this, right, even now. And as you can see, it's plenty fast enough, and it's again, another cool aspect of the system.
The thing that always tickled me is that the print string of an object is a glyph that holds onto the underlying object that you printed.
Okay, I've forgotten that, but
if you print the ordered collection, I think, so that you can inspect the object that gave rise to that print string at any stage, and it lives in the text.
Yeah, so
Doing
right.
projects.
So there's that the when the type checker gives an error, it brackets the error with these arrows. They're actual glyphs, and the idea is you could click on them and get more information. Though I don't think I ever implemented that. So again, it really went a step beyond standard text editors and did it, and it's pretty damn hard to get this to perform. Right, because you don't want every character to really be a glyph, right? You have to sort of figure out how to optimize this, and it's rather complicated. And Dave Griswold did it, but it works, and it's kind of cool. So that pretty much sums up this. Let's see if I had anything more to bore you with. Yeah, well, it's basically So this was finished in '96, February 14th, '97. Sun bought us, and this got dead and buried. We all went off to do our important Java work. And I eventually, after 5 years or so, managed to convince them to open source the Smalltalk layer by promising that we wouldn't open source the VM lest it be a threat to our valuable world domination. Of course, no one cared, and in 2006, just before I left Sun, coincidentally, we managed to open source the VM, and still no one cared. Well, Steve Ruiz cared, but that's about it. It's all BSD licensed, which is important because there's a lot of technology there, some of which is patented, but it's it's all C++. It's about 80,000 lines of C++ and 80,000 lines of Smalltalk. The entire system. This is the original website. We put it out. That stuff's pretty old. Probably the latest stuff is Steve's stuff from here. And here's the conclusions, which were our conclusions in '96. And this is the one I like. Will be part of a commercial product in the near future.
It was Java.
Yeah. So be careful. It's
actually turned true.
But not the way. Anyone know Edgar Allan Poe, The Monkey's Paw? Be careful what you wish for, etc. If not, it's a good story. But that's kind of where that ended. So these are the people involved. Lars, who's now done V8, did Hotspot, did this, did Self, did a couple of other things, cool things. I'm not sure how many people know about the Resilient Smalltalk VM for embedded systems. Did another VM, did mobile Java VMs, etc. Stefan was with Stefan Graf. Now he runs the VMware's research and facility in Aarhus in Denmark. And he was involved in a lot of these things as well. Robert Griesmer, now at Google, one of the co-designers of Go. Dave Griswold started the startup, etc. Urs Hosle, senior VP at Google. These things are too small for him now. He's moved on to a whole other level. Srđan Mitrović joined us late in the project to help with the Java VM, and he's at Google as well. So it's I was very privileged to work with that team. I've never seen anything like it. So, I should mention Steve Ruiz, who is still working on this. He's doing a Cocoa port using the Newspeak GUI, which is why I'm interested in it, actually, because I want him to do that Cocoa port. And as I said, at this point, it's kind of history, and I'm not sure how it can apply to the real world anymore, unfortunately. Might apply on servers, but there's a big learning curve, right? And it would be interesting, because if you want a efficient, compact Smalltalk on ARM, you could take this and then get an ARM compiler instead of the x86. It's no small task, but you might actually get something that really was viable, because it's small enough that you could put it inside an iPhone and you could still have room for your application, and it will probably run rings around Objective-C. So there's still interesting technology in there, but it's a big learning curve, I admit. We're done. Sorry for running over. And thank you very much for coming. Alas, yes.
I have a question.
Yeah?
Do you think it's worth adding
do you think it's worth adding some type inference on top of the type? Or maybe you already...
I skipped it. The short answer is, well, somewhere there's a slide that says, why is type inference not enough? Because, first of all, you could add type inference. You have to be very careful what you're doing. What you might want to do is to add type inference in the IDE. That is, it is a browser function. It is not a language function. It is not part of the type system. That is a mistake. That's what the ML people have done, and it's an ongoing disaster. Though they swear it's the greatest thing in all of history, but it isn't. Type inference that leaks, classical, like depending which. If you tie it to the language, you have to specify what it does, and you get tied to particular algorithms like Hindley-Milner and stuff like that. First of all, there's tons of research that has shown that Hindley-Milner simply does not work for object-oriented type systems. It doesn't get you anywhere. It just can't. The other issue is that it leaks implementation information. You are inferring it from the implementation and then declaring that my interface is that I return a so-and-so. So it's very important that this should capture programmer intent. The advantage of putting it in the IDE is that you could use heuristics, right? You can look at you can put in an optional system, you can look at variable names, right? The Smalltalk convention of saying a foo when the variable is going to hold an instance of foo. You can it has no principle to it. It's just a heuristic. You look at this identifier and say, I'm going to say it's probably a foo, and I'm going to type it as a foo. Nothing bad happens because if it doesn't type check, nothing has changed. The program runs exactly the same. It is absolutely crucial that these type systems do not change the behavior of the type system in any way, which is not true in any statically typed language. It always affects your semantics in some way, and that's a subtle point. And the temptation to do that, because if I knew the type, I could optimize, I could make the rules. People want to be too clever. This is an iron rule. It cannot change the semantics. And Smalltalk will keep you honest because it's a dynamic language and you know what it's supposed to do, right? But you could have an inferencer and it could do whatever it wants. You could go to the browser and say, put in the types, and it'll put in some types, and you can look and say, oh, this is stupid, or I'll just edit it because this is wrong, or I'll type check it and see what happens, and nothing has actually happened to your code. So that's probably more of an answer than you wanted, but yeah.
Thank you. Okay, we have 15 minutes for